Welcome. Today we're diving into the fascinating world of the electromagnetic spectrum. This spectrum is essentially the entire range of electromagnetic radiation, from the longest radio waves to the shortest gamma rays. It's all around us, shaping the way we see, communicate, and even heal. But what exactly does it include, and why is it so important? Let's start by understanding what electromagnetic waves are and how they travel through space, carrying energy and information. As we journey through each part of the spectrum, you'll see how these invisible waves impact our daily lives in surprising ways. Electromagnetic waves are unique because they don't need a medium to travel. They can move through the vacuum of space. These waves are made up of oscillating electric and magnetic fields working together in harmony. Whether it's sunlight warming your skin or Wi-Fi signals connecting your devices, it's all thanks to these waves. Their speed is astonishing, about 300,000 kilometers per second in a vacuum. This property allows them to reach us from distant stars or transmit information across the globe in an instant. Let's explore how these waves are classified based on their wavelengths and frequencies. Every electromagnetic wave has two key properties: wavelength and frequency. Wavelength is the distance between two consecutive peaks of a wave, while frequency is the number of waves that pass a point each second. These two are inversely related. When one goes up, the other goes down. This relationship determines the energy of the wave. Shorter wavelengths mean higher frequencies and more energy. Understanding this is crucial, as it's the basis for dividing the electromagnetic spectrum into different regions, each with its own unique characteristics and uses. Electromagnetic spectrum is divided into several regions, each defined by its wavelength and frequency. These regions include radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Each region has its own set of properties and applications, from broadcasting music to diagnosing diseases. As we move from one end of the spectrum to the other, the energy of the waves increases and their wavelengths get shorter. Let's take a closer look at each region and discover how they're used in our world. The far end of the spectrum, we find radio waves. These have the longest wavelengths and the lowest frequencies. Radio waves are essential for communication. They're used in radio and television broadcasting, cell phones, and even Wi-Fi. Their ability to travel long distances and penetrate through buildings makes them perfect for transmitting information. Next time you listen to your favorite song on the radio or make a phone call, remember it's radio waves making it all possible. Moving up the spectrum, we encounter microwaves. These waves are shorter than radio waves but still quite long. You probably know microwaves from your kitchen. They heat food quickly by causing water molecules to vibrate. But microwaves are also vital for communication, especially in satellite transmissions and radar systems. Their unique properties allow them to pass through clouds, making them perfect for weather forecasting and GPS technology. Infrared waves are next. These are the waves we feel as heat. When you stand near a campfire or feel the warmth of the sun, that's infrared radiation at work. Infrared is also used in remote controls, night vision devices, and thermal cameras. It helps us see in the dark and measure temperatures from a distance. Infrared technology is crucial in medicine, industry, and even in your TV remote. Right in the middle of the spectrum is visible light, the only part we can see with our eyes. This tiny slice contains all the colors of the rainbow from red to violet. Visible light allows us to see the world, read books, and enjoy art. It's also essential for photosynthesis in plants, which supports life on Earth. The next time you admire a sunset or a painting, you're experiencing the magic of visible light. Ultraviolet UV light sits just beyond the violet end of visible light. While we can't see it, UV light has powerful effects. It's responsible for sunburns and helps our bodies produce vitamin D. UV is used in sterilization, as it can kill bacteria and viruses. However, too much exposure can be harmful, so sunscreen is a must when you're out in the sun. UV technology is also used in forensic science and counterfeit detection. X-rays have even shorter wavelengths and higher energy than UV light. They can pass through most objects, which is why they're used in medical imaging to see inside the human body. X-rays help doctors diagnose broken bones and dental issues. They're also used in security scanners at airports. While X-rays are incredibly useful, exposure needs to be limited to avoid potential health risks. The extreme end of the spectrum are gamma rays. These waves have the shortest wavelengths and the highest energy. Gamma rays are produced by radioactive materials and certain cosmic events. They're used in cancer treatment and to sterilize medical equipment. Because of their high energy, gamma rays can be dangerous, but when used carefully, they save lives and advance science. Detecting electromagnetic waves requires special instruments. Radio telescopes pick up radio waves from space, while infrared cameras reveal heat patterns. Our eyes detect visible light, and X-ray machines capture images of our bones. Each region of the spectrum needs its own detector, designed to sense the unique properties of those waves. These tools have opened up new worlds in science, medicine, and technology. Electromagnetic spectrum isn't just for scientists, it's part of our daily lives. From listening to the radio and cooking food to using remote controls and getting X-rays, we rely on different parts of the spectrum every day. Even sunlight, which powers life on Earth, is a mix of visible, infrared, and ultraviolet light. Understanding the spectrum helps us appreciate the technology and natural phenomena that shape our world. Modern communication depends on the electromagnetic spectrum. Cell phones, Wi-Fi, and satellite TV all use different frequencies to send and receive information. Fiber optic cables use light to transmit data at incredible speeds. Without the spectrum, our connected world wouldn't exist. Next time you make a call or stream a video, remember the invisible waves making it possible. Electromagnetic spectrum plays a vital role in medicine. X-rays and gamma rays are used for imaging and cancer treatment. Infrared helps monitor blood flow and detect fevers. UV light sterilizes equipment and rooms. These technologies have revolutionized healthcare, making diagnosis and treatment faster and more accurate. The spectrum truly saves lives every day. Astronomers use the entire electromagnetic spectrum to study the universe. Radio telescopes reveal distant galaxies, while X-ray and gamma-ray observatories detect cosmic explosions. Infrared telescopes peer through dust clouds to see newborn stars. By combining data from all parts of the spectrum, scientists gain a complete picture of the cosmos, uncovering mysteries that would otherwise remain hidden. Remote sensing uses electromagnetic waves to gather information about the Earth from a distance. Satellites use different wavelengths to monitor weather, track deforestation, and map cities. Infrared imaging helps detect wildfires and monitor crop health. This technology is essential for environmental protection, disaster response, and urban planning. Industries use the electromagnetic spectrum for quality control, detecting flaws in materials, and ensuring safety. Security systems rely on X-rays and infrared sensors to scan luggage and monitor premises. Even barcode scanners use light to read product information. These applications keep us safe and ensure the products we use meet high standards. Artists have long been fascinated by light and color, both of which are part of the electromagnetic spectrum. From painting to photography, understanding how light interacts with materials allows artists to create stunning effects. Modern digital art uses different wavelengths to produce vibrant images on screens. The spectrum inspires creativity and innovation in the world of art. Rainbows are a beautiful example of the electromagnetic spectrum in action. When sunlight passes through raindrops, it's split into its component colors, each a different wavelength of visible light. This natural phenomenon shows how the spectrum creates the vibrant world we see. Next time you spot a rainbow, you're witnessing the magic of light and physics. Plants rely on visible light from the sun to perform photosynthesis, the process that produces food and oxygen. Chlorophyll absorbs specific wavelengths, mainly red and blue, to power this vital reaction. Without the electromagnetic spectrum, life on Earth as we know it wouldn't exist. The next time you see a green leaf, remember the invisible waves at work. Night vision devices use infrared light to help us see in the dark. These tools detect heat emitted by objects and convert it into images we can see. Night vision is used by the military, police, and wildlife researchers. It's a great example of how we harness the electromagnetic spectrum to extend our senses beyond natural limits. Wireless technology, from Bluetooth to Wi-Fi, relies on electromagnetic waves to transmit data without cables. Different frequencies are used for different purposes, ensuring fast and reliable connections. This technology powers our smartphones, laptops, and smart home devices, making life more convenient and connected than ever before. Most remote controls use infrared light to send signals to TVs and other devices. When you press a button, the remote emits a coded burst of infrared radiation which is picked up by the receiver. This simple yet effective use of the spectrum makes controlling electronics easy and intuitive. Microwave ovens use microwaves to heat food quickly and efficiently. The waves cause water molecules in the food to vibrate, generating heat. This technology has revolutionized cooking, making meal preparation faster and more convenient for millions of people worldwide. Ultraviolet light can damage skin cells, leading to sunburn and increasing the risk of skin cancer. Sunscreen and protective clothing help block harmful UV rays. Understanding the spectrum helps us stay safe in the sun while still enjoying its benefits like vitamin D production. Both ultraviolet and gamma rays are used to sterilize medical equipment and surfaces. Their high energy destroys bacteria, viruses, and other pathogens. This process is essential in hospitals and laboratories, ensuring a safe and clean environment for patients and researchers. Gamma rays are used in radiation therapy to target and destroy cancer cells. This treatment is carefully controlled to minimize harm to healthy tissue. Advances in technology have made radiation therapy more precise, improving outcomes for patients around the world. Airports and other secure locations use X-rays and other electromagnetic waves to scan luggage and cargo. These scans reveal hidden objects without opening bags, making travel safer and more efficient. Security scanning is just one of many ways the spectrum protects us every day. Forensic scientists use ultraviolet light to detect evidence invisible to the naked eye, such as bodily fluids or fingerprints. UV lamps reveal details that help solve crimes and bring justice. This is another example of how the electromagnetic spectrum aids in important real-world applications. Many celestial objects emit radiation outside the visible spectrum. By observing in radio, infrared, ultraviolet, X-ray, and gamma-ray wavelengths, astronomers can study black holes, supernovae, and distant galaxies. Each part of the spectrum reveals different secrets of the universe, expanding our understanding of space. Climate scientists use the electromagnetic spectrum to monitor Earth's atmosphere and surface. Satellites measure infrared radiation to track temperature changes, while other wavelengths detect greenhouse gases and pollution. This data is vital for understanding climate change and protecting our planet. Wireless charging uses electromagnetic fields to transfer energy from a charger to a device without physical contact. This technology is becoming more common in smartphones and electric vehicles, making charging more convenient and reducing wear on connectors. Fiber optic cables use light to transmit data over long distances at high speeds. The light bounces through the cable, carrying information for internet, TV, and phone services. This technology relies on the properties of the electromagnetic spectrum to keep us connected. Lasers produce highly focused beams of light used in everything from surgery to barcode scanners. By controlling the wavelength, lasers can cut, weld, or even correct vision. This precise use of the electromagnetic spectrum has transformed many industries. Spectroscopy is a technique that analyzes the light emitted or absorbed by substances. By studying different wavelengths, scientists can determine the composition of stars, chemicals, and even food. This method is a cornerstone of modern science, revealing details invisible to the naked eye. Exposure to different parts of the electromagnetic spectrum can affect our health. While visible light is generally safe, too much UV can cause skin damage, and excessive X-rays or gamma rays can be harmful. Understanding these risks helps us use technology safely and protect ourselves from potential dangers. Many household devices use the electromagnetic spectrum, from microwave ovens and Wi-Fi routers to TV remotes and LED lights. These technologies make our lives easier, safer, and more entertaining. The next time you use a gadget, think about the invisible waves at work behind the scenes. As technology advances, we're finding new ways to use the electromagnetic spectrum. From faster wireless networks to advanced medical imaging, the possibilities are endless. Scientists are exploring terahertz waves for security and communication, opening up new frontiers in science and industry. Because some electromagnetic waves can be harmful, governments and organizations regulate their use. Limits are set for exposure to X-rays, gamma rays, and even radio frequencies. These regulations protect public health while allowing us to benefit from the spectrum's many uses. Learning about the electromagnetic spectrum is a key part of science education. It helps students understand the world around them, from how we see colors to how we communicate. Educational tools and experiments make the spectrum accessible and exciting for learners of all ages. Innovators are constantly finding new ways to harness the electromagnetic spectrum. From wireless charging to quantum communication, these breakthroughs are shaping the future. The spectrum is a foundation for progress in science, technology, and industry. Environmental scientists use the electromagnetic spectrum to monitor pollution, track wildlife, and study ecosystems. Infrared and ultraviolet imaging reveal details invisible to the naked eye, helping us protect the planet and its inhabitants. Electromagnetic spectrum is a powerful force in our lives, shaping everything from communication and medicine to art and science. By understanding its regions and uses, we can appreciate the invisible waves that connect and protect us. The spectrum's influence will only grow as technology advances, opening up new possibilities for discovery and innovation. As we look to the future, the electromagnetic spectrum will continue to inspire scientists, engineers, and artists. Its mysteries are far from fully explored, and new applications are being discovered every year. By learning about the spectrum, we equip ourselves to understand and shape the world of tomorrow. Thanks for joining this journey through the invisible world of waves.